Hey guys, my name is Shreyas and welcome to Simple Chemistry. In this video we're going to be talking about percent yield. Okay, so sometimes a reaction does not produce as much product as expected. Okay, so we've been assuming that all these reactions, whatever you started off with, everything, all of it is going to go into reactant, is going to convert and turn into products, but sometimes that doesn't happen. So percent yield describes how well the reaction went to completion. And this is a formula for percent yield, and we're going to be using it in order to solve a lot of questions that I have here. So you can learn how to calculate the percent yield of a reaction, okay? So let's look at this first example here. So 15 grams of CH4 combust to produce 27 grams of H2O. What is the percent yield of the reaction? Okay, so before we do anything, let's first get the reaction. So, write the chemical reaction. So we know that in combustion, you have a hydrocarbon here, CH4, is going to react with oxygen, O2, to produce carbon dioxide and water. And we need to balance this chemical equation. In order to balance that, there are 4 hydrogens here. There are just 2, so I can put a 2 here as a coefficient to get 4. And now there's 4 oxygens on the product side, and there's just 2 on the reactant, so if you put a 2 here, and everything is balanced. Great. So from here, what we're going to do is we're going to calculate how much water should be produced if 15 grams of CH4 react, and that's called the theoretical yield, and then the actual yield is given to us here. It says that 27 grams of H2O is produced, so that's the actual yield. We're going to divide the actual yield by the theoretical yield and multiply it by 100 to get the percent yield, okay? So first step is to find how much H2O would have been produced by the reaction of 15 grams of CH4. Should be. That's called a theoretical yield. Okay, so let's look. Grams of H2O is what we're looking for, and we're given 15 grams of CH4. Okay, so from here we can convert to, first step is to convert this to moles. So 1 mole of CH4 has a mass of, carbon has an average atomic mass of 12.011, and hydrogen has an average atomic mass of 1.008, and we can multiply that by 4, we get this. So 16.043 is the molar mass of CH4, 16.043 grams. Okay, and then from here, we can use the mole ratio. The reaction is telling us for every 1 mole of CH4 that reacts, 2 moles of H2O is created. So for every 1 mole of CH4 that reacts, 2 moles of H2O are created. And then finally we can convert moles of H2O to grams of H2O, which is what we want. So for 1 mole of H2O has a mass of, if you look here, the average atomic mass of hydrogen is 1.08. There's 2, and then add that to the average atomic mass of oxygen, which is 15.999. And then we'll get 18.015. So 18.015 grams of H2O. Okay, excellent. Then grams of CH4 cancels out with grams of CH4. Moles of CH4 cancels out with moles of CH4. Moles of H2O cancels out with moles of H2O, and we're left with grams of H2O. Excellent. Okay, so from here, let's go ahead and do the math and actually type this into our calculator. So multiply the top, 15 times 1 times 2 times 18.015 divided by 16.043 times 1 times 1. Okay, so and we're going to get this. And our answer needs to be rounded down to 2 significant digits because this number has 2 significant digits, this number has 5. These are exact numbers, the 2, the 1, and the 1, as well as this one, and then here we have 5 significant digits. So we're going to have to round this answer down to 2 significant digits, which will give us 34 grams of H2O. Excellent. Okay, so from here, so this is what's called the theoretical yield. So it tells us how much should be created. The theoretical yield. Now the actual yield is given to us here, because this is telling us how much is actually created, okay? So the formula is the actual yield divided by the theoretical yield times 100. So we're going to take 27, divide it by 34, and multiply it by 100. And when we do that, let's go ahead and see what we get. 27 divided by 34 times 100, and we're going to get 79%. So that is the percent yield of this reaction. So what it's telling us, this percent yield is telling us, is that 79%, the reaction went to 79% completion, or the percent yield is 79%, same thing. Okay, let's go ahead and do one more practice problem. A reaction N2 plus H2 yielding NH3 has a percent yield of 65%. So this question is giving us a percent yield, so we're going to have to do something a little bit different. A scientist reacts 32.2 grams of N2. How much ammonia should she expect to end up with? Okay, so first things first, let's balance the chemical equation here. So there's 2 nitrogen atoms on this side. There's only 1, so we can put a 2 here to get that to balance. And then now we have 6 hydrogen atoms here and only 2, so we can put a 3 here. And everything is balanced. Excellent. Okay, so from here, so the question's asking us, it tells us that 32.2 grams of N2 is reacted. It says how much ammonia should she expect to end up with. So what we can do is we can, if you look at the formula here again, we have the percent yield, okay? We have the percent yield, which is 65%. We have the, we can calculate the theoretical yield given this information here, because we know that 32.2 grams of nitrogen reacts. So using stoichiometry, we can calculate the theoretical yield. And then since we have the percent yield and the theoretical yield, we can use algebra to solve for the actual yield. Okay? So first step is to calculate the theoretical yield. So let's see how much ammonia should be created, assuming that the reaction goes to 100% completion. So basically calculating the theoretical yield. All right, so in order to do that, we're going to see how much ammonia should she expect to end up with. So that's what we're looking for. We're looking at the theoretical yield, how much ammonia should be created, assuming that there's 100% completion. And what we're given is 32.2 grams of N2. So let's go ahead and first convert this to moles. So 1 mole of N2 has a mass, let's see, nitrogen has an average atomic mass of 14.007, and then you can have to multiply that by 2. So the average atomic, the molar mass of nitrogen gas N2 is 28.014. Okay, and then from here, our chemical reaction is telling us that for every 1 mole of N2 that is reacted, 2 moles of NH3 is created. So we can use that mole ratio. So for every 1 mole of N2 that is reacted, 2 moles of NH3 is created. And finally, now that we're at moles of NH3, we can convert that to grams of NH3. So 1 mole of NH3, nitrogen has an average atomic mass of 14.007. I'm going to have to add that to hydrogen's atomic mass multiplied by 3, since there's 3 hydrogens, and we'll get 17.031. So 17.031 grams of NH3. Okay, so from here, grams of N2 cancels out with grams of N2, moles of N2 cancels out with moles of N2, moles of NH3 cancels out with moles of NH3, and we're left with grams of NH3. Excellent. Let's go ahead and multiply everything out. So 32.2 times 1 times 2 times 17.031. All of that divided by 28.014 times 1 times 1. And we're getting this. Our answer needs to be rounded down to 3 significant digits because this number has 3 significant digits, this number has 5. We ignore this, and then this number has 5. So 3 significant digits, this rounded to 3 significant digits is 39.2. Okay, so 39.2 grams of NH3. Okay, so this is the theoretical yield. Okay, so this is assuming that the percent yield is 100%. It's assuming that all of the NH3, all of the N2 is reacting and forming NH3. Okay, so this is the theoretical yield. So now let's solve for the actual yield, okay, which is what this question is asking for. So let's look back at the equation here. The percent yield, it's given to us, so 65%. Let's go ahead and write that down here. 65% equals the actual yield, which is what we're solving for. So let's just call that x, over the theoretical yield, which we have here, 39.2, times 100%. Okay? Times 100%. So I'm just plugging everything in. We're going to solve for the x here. So first things first, we can just use basic algebra and divide each side of the equation by 100. So divide this by 100%, divide this by 100%, and we'll get, this will turn into 1 here, and we'll have 0.65. And then from here we can multiply both sides of the equation by 39.2. So 39.2 will cancel out 39.2. Here we can also multiply with 39.2, and then we're going to get x. Okay, so x will equal 0.65 times 39.2, which is 25.48. So that's going to be our answer, 25.48. Well, we have two significant digits here technically, so we would just say 25, I guess. So the actual yield, how much a scientist is going to end up to expect with, is, let me just write it here, 25 grams of NH3. Okay? Pretty simple, you know, just you have to use this formula here, okay? So we've done these two example problems. Let's go ahead and do one last one here. A reaction has a percent yield of 33%. The following reaction ends up with 6.2 grams of H2O. How much O2 should you start with in order to get 6.2 grams of H2O? So we have the reaction here. Let's first go ahead and balance it. So we have 2 hydrogen atoms here, just 1, so we can put a 2 here. And then now we have 4 hydrogen atoms here, we have 2, so we can put a 2 here, and the reaction is balanced. Okay, so let's see here. This question is giving us the percent yield of 33%. Okay, it's giving us the percent yield. It is giving us the actual yield. Okay, it's giving us the actual yield here. Okay, so, well, okay, wait, that's wrong. Yes, it's giving us the actual yield here. So, what we're going to basically have to do is, it's telling us that the reaction ends up with 6.2 grams of H2O, okay? So that's the actual yield. So first step, let me write this down. First step is to calculate the theoretical yield. Okay, and then from there, use stoichiometry to see how much O2 you should start with. Okay, because it's telling us that the reaction is producing 6.2 grams of H2O, but the reaction only has a 33% yield, right? So what we need to do is kind of account for this 33% yield, and then only then can we find how much O2 you should start off with, okay? If you just took this 6.2 grams of H2O and started working out, you get the wrong answer because you're not accounting for the percent yield, okay? So let's look back here. The percent yield is 33%. Gives us information here. We have the actual yield, which is 6.2 grams of H2O. We're looking for the theoretical yield, which is x, and then this is always multiplied by 100%. So first things first, we can divide each side by 100. We'll get 0.33 here. This is just turning into 1. And then from here, we can go ahead and cross multiply and divide. So once we get that, so 0.33 times x is 0.33x times 6.2 times 1, which is just giving us 6.2 grams of H2O. Basic algebra, really. And then 0.33, divide that on both sides to just get x. And when we do that, we will get 6.2 divided by 0.33, we're getting this, so 18, so 19. So 19 grams of H2O. Okay, so this is the theoretical yield. So from now that we've kind of corrected for the percent yield, you know, like we've accounted for the percent yield here with our equation by solving for the theoretical yield, we're going to use this number here. We're going to use this 19 grams of H2O. We're not going to use the 16.2 grams of H2O in order to find out how much O2 you should start off with. Okay, so let me erase all of this. Okay. Essentially what we're doing, if you're still confused, is we're kind of working backwards here, right? This slide, this question here asks us to calculate the percent yield given how much reacts and how much is produced, right? So here what we're doing is it gives us a percent yield and we're working backwards, really, okay? So we calculated the theoretical yield. Now we can use the theoretical yield only to find how much O2 you should start off with. So we're looking for grams of O2. We're given 19 grams of H2O. And let's first convert to moles. So 1 mole of H2O has a mass of, I think we calculated this earlier, it was, 18.015 grams. The reaction is telling us for every 2 moles of H2O which is created, 1 mole of O2 is consumed, so we can use that. For every 2 moles of H2O which is created, 1 mole of O2 is consumed. And then finally, from here, we can convert 1 mole of O2 to grams of O2, which is, so we're going to have to take 15.999 and multiply that by 2 in order to find the molar mass of O2. And that will give us 31.998 grams. If you're a little confused in this video on how I got these numbers, you need to go back and review all the videos on calculations using the mole, because we talked about molar mass and how to get these numbers and what the mole is and all those things. The thing with stoichiometry is it starts to build up, you know, so you have to be good at previous concepts in order to understand more complex concepts like this. Okay, so anyways, so grams of H2O cancels out with grams of H2O, moles of H2O cancel out with moles of H2O, moles of O2 cancel out with moles of O2, and we're left with grams of O2, which is what we wanted. Okay, and then from here, we can just go ahead and multiply 19 times 1 times 1 times 1 times 31.998. Okay, and then divide that by the products of the bottom, so 18.015 times 2 times 1, and then that will give us this answer, 16.873, and our answer needs to be rounded to 2 significant digits because this number has 2 significant digits, 19. This number has 5. We ignore these numbers 1 and 2, and this number has 5. So our answer needs to be rounded down to 2. So this will be rounded down to 17 grams of O2. Okay, and that's our final answer. This is how much you start off with. If you wanted to see if this answer was correct, you know, what you could do is you can convert this, you can kind of work backwards here. So we know that 17 grams of O2 must react. So what you can do is, this right here is the, is how much you should start off with. So you can use this equation here, the the percent yield equation in order to calculate the actual yield of the reaction, right? So you can take 17 grams of O2, we have the percent yield, and then use that in order to work like forwards, you know, and get and see if you're going to end up with 6.2 grams of H2O. You know, just work all the way back in. You know, start off, assume that you don't know this information here. The reaction ends up with 6.2 grams of H2O. Assume that you don't know that, and just work backwards. You know, and you should get 6.2 grams of H2O. It's like just basically working back and forth in order to see if you're getting the same answer. Okay, I'm not going to go ahead and do that because you should be smart enough to do that at this point. But I hope this video helped. Percent yield is as simple as that.